In this tutorial, we will explore the concept of base slope in PVsyst and its impact when importing projects from other 3D software. The concept of base slope refers to the effect observed on solar panels when they are positioned on sloping ground. This phenomenon occurs, for example, when the panels are installed following the natural slope of the land, creating different orientations. When defining fields in a shading scene in PVsyst, the software attempts to automatically identify the orientation of the fields, grouping those that are similar. Let's see why the base slope is crucial in importing complex 3D scenes with the varied topographies. On flat ground, the azimuth and inclination of the PV tables remain constant and the terrain has no influence. However, panels placed on sloped terrain will adapt to the slope and inclination, resulting in new orientation values. PVsyst groups orientations based on the tolerance of 1 degree between the normal vectors of the PV tables. To better understand this concept, there is an educational tool in PVsyst. To access this tool, click on Tool in the menu bar, then on Orientation Understanding, Educational Tool. This window presents two panels with the same orientation, normals being identical. If the inclination of the first panels is changed to 20 degrees, the difference between the normal vector reaches 10 degrees. The base slope tab illustrates the result of the normal vector after applying the base slope. If we start with nominal inclination of 30 degrees and an azimuth of 0 degrees, then add 5 degrees to the base inclination, the real inclination azimuth box shows values slightly different from the nominal plane. Here's another example. If we set an inclination of 1 degree and apply a base slope of 5 degrees, you observe that the real azimuth is 78.7 degrees, whereas the inclination of 20 degrees, you observe that the real azimuth has dropped to 13.5 degrees. This is because we measure the normal vector to the PV plane. With the varying inclination, we observe that the real azimuth in red varies significantly. Now consider an imported scene. We had defined a nominal inclination of 20 degrees and an azimuth of 0 degrees in the 3D software with a specific topography. PVsyst generate 8 different orientations with a tolerance of 1 degree between each nominal vector. By clicking on each orientation, we can visualize them on the 3D scene. It is unrealistic to electrically wire each table corresponding to the orientation that PVsyst has identified considering a tolerance of the normal vector of 1 degree. It could therefore be interesting to increase the tolerance of the identification of normal vectors in order to reduce the number of orientations in PVsyst. In automatic identification, adjust the tolerance of the angles between the normal vectors of the PV tables. To reduce the number of orientations, increase this tolerance. For example, by setting the tolerance of 20 degrees and clicking on Identify Orientations, then the validation on the warning window, you will find that all the tables are grouped under one single orientation.